Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
So I'm standing here going to present our works. Okay, in the beginning of this part it's chameleon. But why is chameleon? Chameleon has the ability to adapt. To its environment. It can change the color based on its environment, based on the situation that he faced. So it's in a similar way, smart energy method has the ability, has to require the ability to adapt to its time, to current technologies, to recent technologies. Next. So our work is about analysis of data communication utilization on smart energy method. Our thesis our team consists of Arjuni Budi Pancawati, Aib Saripudin, Muhammad Husni Mutakin, Intar Ali Fahristiana, and me, Fikri Fauji, as the presenter of this work. Next. Okay, the introduction. Energy measurement system challenges arise in power management systems and transmission range control as energy requirements continue to increase. The development of energy measurement system is directed at the effective, sustainable, affordable, and safe use of energy in the future. Smart energy measurement system enable users and service providers to communicate effectively together to realize more optimal resource management. So this paper describes the evolution of data communication technology in detail, starting from metering infrastructure, metering communication control, and metering communication network. Next. So this is the evolution of smart energy method. The first one is mechanical method. Its features are robustness, mechanical dial of energy method, no use of battery. And its disadvantages are very inaccurate, no communication, no display, only counter, no self-diagnostic, and typical installation. And the second one is electronic method. The features are, it has the prevention of theft and detection, temper immunity, accurate for load control, LCD display, high ESD immune. And the disadvantage are wired communication, no self-diagnostic, no smartphone. And the last one are smart method. Its features are very accurate, theft prevention and detection, temporal locking, LCD display, wireless communication, remote load control, self-diagnostic, interoperable with standard protocols, smartphone connectivity, and its disadvantage is costly or expensive. And this is the evolution of metering infrastructure. The first one is MMR, or manual meter reading. The data collection is done manually by humans by reading the data displayed on mechanical meters. The second one are AMR, or automatic meter reading. Meter reading data is transmitted to the utility via wired or wireless communication through an intermediate node known as a data concentrator. And the third one is AMR, or advanced meter infrastructure. Electrical consumption data transmission is transmitted directly to the utility wirelessly using GPRS or GSM modems without going through concentrators. And the next one is metering data communication. Metering data communication we categorize as three types of communication. With two communication. It is wired and wireless. And we have three types of wired communication here. The first one is power line carrier or PLC. PLC is the first communication technology used in STM systems that utilizes the presence of power line cables, which have coverage in the order of kilometers, and data rates can increase up to 500 kilobits per second. The second wired data communication is digital subscriber lines or DSL. This high-speed digital data transmission technology uses telephone network cables with a coverage range up to 5 km and the data ranging from 1.5 to 100 megabits with a latency of 10 to 70 milliseconds. The third one is fiber optic, one of the most visible means of communication used in wide area network or WANs. Is fiber optic technology, thanks to its resistance to signal interference or noise immunity and high data rates up to 40 gigabits with a very low latency. Matching data communication, there is wireless. The first one we have ZigBee. ZigBee is micro power wireless technology based on IEEE standard, a highly efficient standard for peer-to-peer and personal area network. Second one is Bluetooth, a wireless communication technology designed for short distance data exchange, offering fast data exchange and low power consumption. And the next one is Wi-Fi. The technology is based on IEEE standard 2 and offers medium to high range coverage and data rates. And then we have LoRaWAN with a comprehensive range coverage up to 15 km in rural area, low power consumption, affordable cost, and low data rates with a low maximum bandwidth about 5.5 kilobits per second. LoRa cannot transmit audio or video. It can only transmit simple information such as sensor values. The next one is cellular networks. Cellular networks technologies such as GSM, GPRS, LTE, and 5G are suitable for communication subsystem elements and data management system in SAM application. And the last one is satellite network. Satellites can provide global connectivity, especially beneficial in remote and rural areas that lack other telecommunication infrastructure, and for high-speed moving platforms such as planes and ships make them suitable for application in wide area networks or WANs. Next. So, matching communication network. It consists of 4 types of communication network. There are HAN, home area network, wide area network, FAN, FAN, field area network, and NAN, neighbor area network. So this is the communication technology comparison for SAM that I present before. So it's communication technologies for SAM. Compares communication technologies used for SAM regarding transmission media, data rate, range, and network application. Its technology has disadvantages and its advantages. So its utilization is influenced by various considerations such as technology and infrastructure readiness and geographical and economic condition. And then two-way communication. Two-way communication capability is the most significant difference between conventional and smart measurement systems. Remote intelligent sensing systems allow for automated energy measurement and data processing to make decisions in real time. And the last one is fiber to the home, or FTTH. In this regard, focus on intelligent data transmission management system infrastructure by proposing using fiber to the home or FTTH-based gigabit passive optical network or GPON networks. So for the usage of the FTTH, according to the Ministry of Communication and Information Technology, Kemenko, in 2023, Indonesia has a fiber optic totaling 459,111 kilometer in the total of length. The use of FTTH network at PT Telkom with an IndiHome platform in 2022 of 37 million users has a fluctuation in the tendency to increase yearly. In the annual report of PT Telkom, it is shown that the usage of the FTTH network increased by 3.3% from 2021 to 2022. And the operation of the downstream and upstream traffics in GPON. GPON is fiber optic based access technology that enables two-way data transmission from service providers to customers via fiber optics at gigabit speed with a coverage range up to 20 kilometers. GPON has a main component. It is OLT or optical line terminal on the service provider side and ONU optical network unit on the customer side. GPON uses TDMA, time division multiple access, as a multiple access technique on the downstream traffic from OLT to ONU with the nominal bit rate specified in ITU D984.2. Recommendation is around to 2488.32 megabit per second. On the upstream traffic from ONU to OLT, GPON use TDMA, time division multiplexing, with a bit rate of 1244.16 megabit per second. So the conclusion is, through the development of SAM data transmission, network infrastructure using FTTH-based GPON integrated IoT can contribute to the configuration of data transmission networks to improve SAM. The performance in terms of efficiency, reliability, and security of transmission system. Data transmission networks using FTTH can transmit measurement parameter data to users in distant locations with high speed and large capacity. It can improve SAM resources and services to ensure the required level of energy quality. So for further investigation, solutions for using SAM refer to something other than the best technology, but more precise technology depending on several factors such as infrastructure or geography of the area. The most appropriate SAM communication technology for application on smart grid in residential homes is fiber optic, due to several factors such as coverage area, the data rate and others. For future research, we can apply FTTH integrated IoT to improve SAM resources and services that can ensure energy quality. So that is all from me. Thanks for all. Thank you very much. See you next time. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for a faithful presentation.